I'm working on several projects related to research and in social science, and for companies also that we have a collaboration, basically applying machine learning techniques to solve business problems. And also I'm a STEMA professor in 2 courses in SKEMA. Okay, so I have a background in computer science, but also in business. Okay, so this is the outline of the presentation. So basically, I'm going to give an introduction of the transformer model because now and these days even more with the irruption of ChatGPT is in the everywhere mouth, you know. But I noticed a few months ago that people don't know like the basic idea of how they work, because a lot of people ask me in the university or in classes that, okay, they are wonderful, but it's like they are magic, no? They don't know how they do the wonderful things that we are achieving since they were created. So my objective with this presentation is just to teach or to show the general idea for the ones that are not non-technicals, that have no technical background, to just to know that I hope that after this presentation you have the main idea of how they work, and after you hear new things you will say, okay, now I understand better. So feel free to interrupt me anytime, so because I want that everything is perfectly understood. So okay, for starting, for those who don't know, maybe you have hearing a lot of time about neural networks, neuron, etc. But what is a neuron? So the idea in computer science of artificial neuron came from as 90% of the things in computers or in science, we got the idea from nature. So an artificial neuron has the same structure of a biological neuron, where you have like a cell, like the brain, no, of the neuron, and you have connections to receive an input, an electrical input in the biological neuron, and it develops a chemical reaction inside the cell of the neuron, and it gives an output, another electrical current to the next connection in case some rules are applied. No, so for example, we should learn, you know, very generally, the neurons learn by repetition of tasks. How do you learn to ride a bike or to swim? You don't learn like thinking constantly, okay, now I now have to move one leg, the other. You learn like by repetition, failure and success, you know. So basically that's the idea of artificial neuron, that you have, I hope you can see my course, okay, my mouse. So you have a core, which is like basically an equation with coefficients, and you receive an input, which are parameters, and this equation gives a result, an output. Okay, so and this output can have different meanings, depends of your application. Okay, and also this artificial neuron learn to solve tasks by repetition, which is called one of the fields of machine learning, which is called supervised learning. Okay, so these coefficients are adapted, are changing to measure, to match the output that we want to have. Okay, so this is like the schema of one basic neuron, but we have neural network, which are combination of different neurons which concatenate the output of one neuron with the input of the following one, so we can create bigger structure of equations, and we can solve more complex tasks. So in the last decade, we have gotten a huge progress in the neural networks development. Okay, at first, like 15 years ago, we just used one simple neural network, which are called multi-layer perceptron, which was the theoretical part of the development of this was in the 60s, so it's like really old. But with the computational power developed in the last years, basically mostly with the introduction of the GPUs, this structure leveraged dramatically. Okay, so this first structure was used for general purpose. We used the same structure of neural network for try to solve any task. So this structure was getting more and more complex, and then the next step in the evolution was to develop a particular structure for a particular problem. For example, to solve visualization problem, which computer vision, etc., image or video recognition, etc., we develop convolutional neural networks. And for text processing, we develop recurrent neural networks. So two different kinds of neural network structure specialized in solve a particular task. Okay, so we're going to focus at first in the right part, in the text part, in the recurrent neural network, which is our objective. Okay, so this was basically the general idea of a neural network until 5 years ago, where a group of researchers for Google released a paper which called Attention is All You Need in 2017, where they proposed a new kind of architecture, of neural network architecture, which is called transformers. Okay, and you can see the impact of this work. And up to date, they have more than 65,000 citations. So for those who are researchers, can see that this is a really, really high impact. Okay, so this architecture literally transformed our conception of what artificial intelligence or neural network can do for us, the kind of tasks that they are able to solve. Okay, and they, in just 5 years, they have been implemented in many fields, and they have gotten like huge success. For example, part of the Tesla Autopilot to develop autonomous driving use transformers. The most interesting for us is GPT-3, which is part of ChatGPT. It's a model just to generate the realistic text. Okay. Also, for example, in the field of biology, they have developed AlphaFold 2, which has made a huge revolution in biology because it's used to model a structure of the proteins. Okay, and in the terms of image, last year was released in Dall-E 2, which is the same company that ChatGPT developed this model, which is able to generate picture illustration for a description of a text. And just a quick funny story in case you don't know, Dall-E 2 is proprietary. It's a private company. They charge you to use it, and there was a very rich, computer scientist from the United Kingdom. It was originally from India. He said, okay, this is a really huge technological development. I want to be free for everyone. So from his own money, he created Stability AI, a company. He hired a lot of engineers from OpenAI, from the competitor, and they developed like a open source version of Dall-E, which is called Stable Diffusion, and just to release for free for everyone. So they don't make any money. They just invested a lot of money to train the model, and to have available for free. So now Stable Diffusion is really popular because it's free for you to use it. Okay, so also was developed in the context of GPT in GitHub Co-pilot, because okay, I will enter in more detail later, but basically this huge transformer model, they are trained with huge amount of text. Okay, so they say, okay, we have developed GPT-3, GPT-2, and it's able to generate text. Okay, but they thought, okay, for example, now we can, why programming language is also text? So why we cannot we train this model, but instead of regular text, plain text with code from GitHub? So they train a new model with the entire GitHub repository, public or also private, because they have the rights for the code. And they released GitHub Copilot, which is able for a description. It's similar to Dall-E or Stable Diffusion. You write a description of the code that you want to get, and it generates a suggestion of a code, like you have with Dall-E 2, a suggestion of an image. And it has been so huge success that currently more than 30% of the new code that is uploaded to GitHub is written by GitHub Copilot. So a lot of programmers or engineers are using daily. Okay. And I personally have used it, and it's amazing. You write anything, and it gives you a really accurate code. Okay, of course, the last one, the most popular one was ChatGPT, which was as basically is GPT-3, a model to generate text, but it was encapsulated in a chat box. Okay, so they released, I think it was in November or October, and it has been the best success in machine learning, I think, in history, because you can see here in the right in this chart that has been the technology that fastest has reached the most impact in the community. You know, it has been a really huge success. And for those who don't know, OpenAI was a company funded by Elon Musk, and in 2015, but he left the company the year after created, so he's not related anymore with that. And Microsoft, when GPT-3 was released, they saw the huge potential and they invested at first $1 billion, and after the release of ChatGPT, they have invested $10 billion in the company. They don't own the company, but they are like the main partnership of them. Okay, so and thanks to this partnership, the Bing browser or the Edge browser from Microsoft and the Bing search engine is going to integrate soon ChatGPT. I think the beta release is going to be released in a few days. So if you want to use it, I hope it is free. I don't know. Okay, so basically here you have a summary of the increase in dimension of the transformer model since its release. And you can see when we talk here about the size of the model in parameters, the parameters of a machine learning model are just the coefficient of the equation that we saw in the previous slides. We saw that the neuron inside has equations. This equation has coefficients. So each coefficient is called also a parameter. So when you see a model that has 1 billion or 1 million of parameters, just means that has 1 million of equations, you know, with different parameters. So are work together to solve a task. Okay, so they have grown exponentially these models. Okay, for example, only to train the state-of-the-art, the biggest transformer model, which is called Megatron Turing. It was a partnership between NVIDIA and Microsoft. They invested only to train the model in equipment, in computer resources, electricity, $100 million, only to train the model. And GPT-4, which is the evolution of just ChatGPT, is expected to be released during this year, is expected to have 1 trillion parameters, so which is really crazy. So we don't know which is going to be able to solve this model. Okay, so the main research question you can say, and this is how is it possible this huge increase in performance? Okay, and in only a few years. Okay, so we need to back to the beginning on the first model where was able to process text. Okay, the first neural network that processed text before the eruption of the transformer was the recurrent neural network. Okay, so how do they work? Okay, when you see a sentence, how do we process a sentence? We start reading a sentence sequentially, word by word. We start for the first word, for example, in this sentence, the quiet brown fox jumps over the lazy dog. We start processing each word sequentially. Okay, so that's the idea of this recurrent neural network. The recurrent concept comes from the inputs of your network is each word of the sentence, but you process these words in the order that of the sentence, because you know, semantically, you need to keep the order of the words in a sentence, because otherwise you don't have you lose the meaning of the sentence. Okay, so this how does this neural network work is you continue. For example, if you can see my cursor, you process the same word, and the input of the second layer, the second neuron of your network is the output of the first word and the second word. You know, so you keep the information of each word. Okay, so this how this natural language processing worked for 10 years until the eruption of the transformer model. But this has a problem, a huge problem. This kind of processing. Because, for example, if I tell you now, anyone can remember the first word that I said at the beginning of the presentation. It's possible because I have said hundreds of words and you have lost. Your memory cannot keep all of the words. So this is called a short-term memory problem in this kind of neural network, which means that when you are concatenating words, if you concatenate more amount of words, dozens, hundreds, thousands, you are losing the first word, the meaning of the first words. Okay, so the main limitation of this model were that they couldn't process huge amounts or huge text. They only could process like short sentences, short paragraphs, or text. Okay, so the first problem that we need to solve is this memory loss problem. Okay, so fortunately, there is a mechanism to solve this memory loss problem actually in recurrent neural network, which was later exploited also in the transformer. Okay, so how do we solve this problem? Before starting explaining the attention mechanism with this mechanism to solve this memory problem, just for the people that don't know, because you can say, okay, I am processing words, but how do I compute words? Okay, so basically in machine learning, you have one thing which is called word embedding model, which is to process words, the computers only understand numbers. So what we do is to convert each word into a vector of numbers. So this word embedding model will translate the words into vectors of number, where each position of the vectors represent one concept to describe the word. For example, we have cat, we have felling. For example, if it's not human, it is an animal, has 4 legs, etc. So there are models that are able to transcribe and theorize words into numbers. And we process these vectors. These vectors are able to be processed by computers. And the thing is that we can also represent these vectors in the space, and without wanting to enter in so many details, but in a multidimensional space, when you have closer vectors in a space are more similar. So if we project these vectors of word in a space, we can process, we can compute, we can measure the similarity between the words by processing the similarity of the vectors. So if someone has some background in mathematics, for example, in basic mathematics, there are called, for example, cosine similarity. You compute, for example, the cosine of 2 vectors. You can measure with one number the similarity between these 2 vectors. Okay, so basically it's the idea. That's how this neural network can process the similarity between words. So we are going to use this. Okay, so the thing is we want to implement, the idea is we want to keep the information of the word, but not only the information of the words. We want to keep the relation between the words, this relation, this closer relation that I have explained. Okay, so we want to be able to store the meaning or the relation between words, no matter in what position is stored the word in a sentence or in a text. Okay, so for example, we're interested in keeping the relation, for example, in this example sentence. Okay, I want to keep the strong relation between eating and apple because are 2 words that are very related. Perfect. Okay, so for example, in this sentence, we have a meaning and a strong relation between the verb eating and apple, or between green and apple, because are 2 words that their meaning are very related, very interconnected. But for example, green and eating don't have very much relation. So we want to have to be able to get this kind of relation. Okay, because are the relation that give us the information to understand the meaning of a sentence. Okay, so how do we do that? Okay, so the question now is, okay, how do we automatize this search for relation between words in a sentence? Because we can, of course, we cannot do it manually. Okay, so what we're going to do basically is just to compute 2 separated neural networks. Okay, so a first neural network is going to process each word and to get the identifier vector, which is the vector that the translation of the word into numbers. Okay, just with the information of the description of this word. For example, in the case of apple, this number could have the information that I am an apple, I am green or red, I am found in nature, I grow in trees, etc. Okay, and a second vector who has the information of the relation, no? The relation with other words. For example, apple can be related with other fruits, with objects in nature, etc. So we are storing these two vectors for each word. Okay, and we're going to use them to match with the rest of the word in our sentence. Okay, so these are called in literature, etc., key vector and query vector, you know, like a locker and a key. Okay, so basically, for example, we have this sentence. No, we want to understand the meaning of the relation of this sentence. Okay, so we have compute for each word these two vectors. Okay, so what do we do now? As I have said before, if we have vectors of number, we can easily compute the relation between the words using, in this case, the dot product. The dot product, which is just a basic multiplication between vectors, which gives the closer, the closer the vectors are. So with this dot product, we can actually measure if two words are strongly related or not. For example, if we compute a dot product for the words cat and dog, they're going to be very, very close because they're two very similar words. But if I compute cat and, I don't know, car, they are not related, so the dot product is going to be the opposite value. Okay, so and we are going to use this value. Okay, so what do? We compute this dot vector for example, we take the word she, and we compute the dot product for against the rest of the word in the sentence. And this value is the relation of the word. Okay, the higher the value, the closer are the two words. And the lower the value, the more far away, the more distance are the words. Okay, in terms of relation, of meaning. Okay, and we repeat this for all of the words. Okay, so since this value is called the attention value. Okay, and this is the actual value that gives us this high attention or low attention between pairs of words. Okay, so for example, just computing this value, this single value between pairs of words, we can easily see the relation between the words in a sentence. For example, if we compute each word with the rest of the words, all against all, we have a matrix of values. Okay, and for example, in this example of a translation of a sentence from French to English, the white the value is like the higher is the value. Okay, so if it's white, it means that the value is higher, and if it's black, it means that the value is lower. And we can see easily that it is able to get the information of the relation between the words, even though maybe the words are not in the same position in the sentence, because, you know, for different language, the order of the words can change in the sentence. Okay, so it's a really, really powerful and very simple operation. Okay, so what do we do basically? We are going to use this to compute, to solve our memory loss problem. Okay, so we have in one hand this attention value. Okay, so we're going to apply to our recurrent neural network. Say, okay, first I am going to just apply this word embedding, this translation of words into vectors. So I'm going to call the vector associated, the number associated to each word as value vector. Value because it has the value of the word. Okay, and what I am going to do with this value is to multiply. When you multiply things, it's like you are associating things. Okay, so I'm going to multiply this value vector with the attention vector of this word, because this attention vector has the information of the relation with this word against the rest of the word. Okay, so if we add this information to our value vector, we are like adding not only the meaning of the word, but his relation with the rest of the words. Okay, and we add this information with each one of the words in a sentence, and this output vector is like our output vector for this word. So this output vector number 1 has the information of the word she and his relation with the rest of the word in the sentence. Okay, so we just compute this for each one of the words, and with this combination, we have in each word not only his meaning, but his relation with the rest of the word in a sentence. So applying this simple attention mechanism, we have solved the memory loss problem because we don't care if one word is in the position 1000 because we already have stored the information of his relation. Okay, so this is great. Say, okay, recurrent neural network plus attention mechanism is great, but okay, but as you can see, the title of this presentation is not called recurrent neural network plus attention mechanism are great. Okay, so the thing is, we still have another issues, and what these people from this paper, what they said was, okay, this relation is great, but we discovered that we don't need a recurrent neural network. Just with this attention mechanism, we are able to get the same results. So, this change of perspective is really important because it gives us the possibility to process exponentially different sizes of text, because the recurrent neural networks, I didn't say before to detail, is if you are processing sequentially the words, it means that you only can process one word per time. So you are losing a lot of computational resources, because imagine you have a text of 1 million words. It's a really waste of time or computational resource if you need to process one word per time. Imagine if instead of processing one word per time, you could process the 1 million of words at the same time in parallel. So you are dramatically increasing the potential, the powerful of your model. And this is what the transformer did. If we remove the recurrent neural network, we don't need this sequential and really low processing. We can process because for computing this attention value for each word, you don't need the other words. You can process each word in parallel. So you can process all of the words or your text or your database at once, at the same time. So before, we were not able to process huge texts because they took really long time. And now, for example, with the GPUs, that the GPU are devices that are optimized to parallel processing. They are able to process millions and billions of words in seconds. So we are able to process amounts of text or sizes that a few years ago it was impossible, technically impossible to process. Okay, so this is the main idea of the difference between the transformer or the recurrent neural network. But okay, so sorry, this was already explained in this slide. Okay, instead of processing each word sequentially, we are processing all at once. Okay, but it seems perfect, but maybe you can say, okay, but this is great, but I am missing one thing. Okay, I don't need to process sequentially this word, but I am missing something. I also need the position of the words in the sentence, because if I process this sentence at the same time and I don't know if eating is a verb or is it the object of the sentence, it can change dramatically the meaning of the sentence. So it's really important to keep the position of the words. Okay, so it was the second challenge of the transformer, to be able to process in parallel all of the words, but keeping the information of the position of each word. Okay, so this is the schema of the transformer model. Don't worry, you need to understand it. And you can see here a lot of time the attention word, and the most important thing in my opinion that they did, because okay, the attention mechanism was already created. What they did was to create this positional encoding. This positional encoding is a way to keep the information, the position of the words in the sentence. Okay. So, and don't worry, I'm not going to enter in many technical details now. I just need to show but don't worry. and ask me any question you have, okay, in this part. Okay, so basically with this positional encoding, what we can do is to label each word which is position. Okay, for example, the word she, we want to attach to his value the position of the event. So for example, this is the position 1, 2, 3, 4, 5, etc. Okay, so if you think a bit, this is called absolute positioning. Okay, because you are storing the position from 1 to n. This has a problem. And the problem is, imagine if we have only 5 words, it's okay. But when we combine this information to be processed, remember when we combine words, we are multiplying the words, the numbers. Okay, if for example, if we have the first word, if we multiply this word, okay, or we just add this vector, okay. Just a bit of disclaimer in case there are some technical profile here. I am doing some assumption, just to explain things more easy. So maybe this is not 100% accurate, just because I don't want to enter in so many technical details. But okay, imagine that you want to combine these two vectors. This, okay, if you see this number, okay, you are still getting the information of the meaning of the word, okay, because I have 1.52, okay, but for example, I want to process the word 200. Okay, now here, like most of the value of the number is for the position, not for the meaning of the word. And I want, for me, the most important part is not the position, it's the meaning of the word. So this positional encoding, this absolute positioning is not the best option. Okay, so maybe you can say, okay, another solution could be to do is called like relative positioning, which is basically I just, instead of assigning one natural number to its position, I just sum the total number of words. For example, I have 6. I divided each number for the total amount, and I have like a percentage. Okay, 1 6, 2 6, 3 6, etc. Okay, so this way, when I combine this, I am not losing the information of the word. But this position, this relative positioning, also has the disadvantage of maybe I don't know before the size of my text, the length of my sentence. Or maybe if I'm computing a paragraph with different sentence, each sentence maybe have different length. So I cannot assign a global length, because for example, for a 6-word sentence, the 4th word has this value. But for example, in a 3-word sentence, also have the same value, but for a different position. So it's not accurate position. Okay, so we need to find an optimal codification for this positioning. Okay, so the solution comes from the binary codification. Okay, in case you don't know, the computers work with a binary system. Okay, just very brief. We work with a decimal numbering system, which is called decimal with our numbering, because we have 10 different digits to describe our numbering from 0 to 9. Okay, so a binary, and we express any number combining these 9 digits. When we want to count with more than 10, for example, we can count from 0 to 9 with 1 digit. If we want to count, for example, 10 or 11, what we do is to add a second digit, okay, to our system. And this is how we count. Okay, so a computer uses binary codification, which means that they only have 2 digits to express all the numbers, 0 and 1. And we can count any number with this codification system, which is basically, for example, we can count 1, 0, and 1. And we want to count 2, what do? We add a second digit, So 2 will be just 1 and 0. We want to count 3, we count 1, 1. We want to count 4, just add a third digit, and we count 1, 0, 0. Okay, don't worry, because I understood that this thing, the first time that you see it, can be mind-blowing and a little bit difficult to understand, but just to know that you have the idea that it's like a different way to codify numbering. For example, just a historical fact, in French, when we count in French, for example, 80 is 80, 4 times 20. Why? Because historically, in the medieval age, when the French language was being developed, the numbering system in France was not decimal, it was in 20. They count from 0 to 20. So that's how they and the language develop, and they kept this issue. So you can see along history, humanity has had a lot of different numbering systems. For example, we count the months or the hours from 1 to 12 because in Mesopotamia they count with the the origin of the decimal numbering was because in prehistorical ages they count with the fingers, and we have 10 fingers, and the 20, so just say, okay. So just to say that, okay, that there's not only one kind of way to count things. Okay, basically, so we're going to use this binary codification. So how do we do? For example, we have this an example of 3 numbers, 3 huge numbers. So his translation to binary codification is really big. Okay, don't worry, you don't have to understand the translation, just to put it for you. Okay, so we're going to use this numbering to store the position of our words. Okay, and we just need to express this in a way. We need a way to express this numbering, without needing to combine this 10 characters name with our vector of decimal number. So basically, the idea is to, if you can see, we can express these numbers as a way where we have the lower value of the weight with the zeros, and the high value, like a clock, 0, 1, 0, 1, and we express this numbering just as a way. And we know for science, for physics, we have a way to express waves. We start with the waves equations. Okay, it has some background in in high school or in some science class. We used to study this thing in high school, at least that they exist. Okay, so basically we can express a wave with an equation, with sine or cosine equation. So basically, you can see here pose, which is the position of the word. So we just, with the number of the position of the word and with this equation, this is how these people develop a way to store a very, very optimal way to store the position of the words. Okay, in our model. Okay, that's why it's called positional encoding, and that's why the symbol has a way. Okay, so just for you to know the idea. So how do they solve the problem? Okay, so basically what we need to do is for transformer is that the great combination is to have the attention mechanism with this positional encoding, and these two techniques together is what has gotten the possibility for the transformer to get all of these developments. Okay, so basically this is the general idea. And just before finishing the presentation, I want to give you the idea of, at first I present some example in big tech industries of development of transformer, ChatGPT, Tesla Autopilot, etc. But I want for you to know that for me, one of the best things of this model is that we are able to use for most of the people. There's not something that is only for very big, wealthy companies. Only a few amount of workers can use them. We can use it for a lot of daily uses in our daily life. A lot of thousands of researchers in the world or workers in company are using daily. In a small startup, big, small and medium companies, research department from a lot of universities. So thousands of people are using, and they are contributing to reach huge, amazing developments. Okay, for example, there are 2 models that are open source and free for everyone, transformer model. One, the first one is free, it was developed for Google, it's called BERT model. It's called bidirectional encoder representation for transformer. Okay, this is the acronym. It's a transformer model pre-trained. They already trained in big supercomputers and they publish for everyone to use it. And it's trained for text analysis, prediction, and classification of text. Okay, and also, so for you for understand the dimensionality of this model was trained using the entire Wikipedia. Basically, they feed the model with the entire Wikipedia, which has 2.5 billion of words, and the entire book corpus of Google, who has more than 7,000 books with more than 800 million of words. Okay. Also, the second one, which is called GPT-2, is the previous version of ChatGPT-3, which was released for free. This company first released ChatGPT-2 for free. People use it a lot, became very popular, and then they released an improved version that you need to pay for it. But a lot of researchers also then are using the previous version because it's the one that is able for the general public. Okay. Also, apart from the integration of ChatGPT-3 in Bing or in Edge, also thanks to the investment of Microsoft in this OpenAI company, also if for example, Power BI, because a very, very popular tool in business, Power BI already has integrated ChatGPT-3 in his pre-trained models for machine learning. So if some of you use, for example, sentiment analysis in Power BI, they are implemented using these tools, this transformer model. Okay, just if you're interested to know. For example, another open source tool of transformer model is called BERT-topic. BERT-topic is a topic modeling technique. Basically, if you don't know, a topic modeling technique is just a machine learning technique which is able to abstract from a text to cluster, to summarize all of the words in a text between groups according to the meaning of the words. For example, you have a text talking about, a holidays, vacations. So this technique is going to keep to summarize words related to the travel in a separate cluster, words related to the food, etc. Okay, so and thanks that this transformer model are really, really good in keeping the context, the whole context of the sentence, thanks to this positional encoding, these techniques now are really, really, really much powerful. Because before the transformer, these techniques were really, really naive, and they just process each word separately without any information of the context. And now we can have the context of the sentence, which is really, really important for understanding the text. Okay, so for example, on our site, I am doing research in collaboration with SKEMA in different research papers using transformers. For example, one very quickly is to apply transformer model to characterize or to understand what makes an online review, for example, for Amazon, trustworthy. Trustworthy means a review that you can trust and is helpful for you, but is truthful. It's real. It's not a fake review, which nowadays are becoming really, really popular. So we are using this BERT and GPT-2 model to train a machine learning model to understand this kind of reviews. For example, just a very summary of the general structure of the model is, with GPT, you can generate text. As when you ask things to ChatGPT, it's generating text. So we have trained a GPT-2 model to generate artificial reviews, fake reviews, artificial. And we have real reviews from trustworthy sources from Amazon. And now we are, with these two sources of reviews, artificial phase one generated for us and real ones, we are training a BERT model to learn how to classify, how to understand the difference between these two kind of reviews. Okay, so basically that's how we are using them. Okay, and then, to do the social side research with this result. Okay, another example is with this topic modeling. For example, we are analyzing, understanding customer behavior in marketing on restaurant online reviews using, for example, this BERT topic modeling. We're applying this transformer model BERT to cluster, to summarize, to understand the different meanings, the information which is captured in the online reviews from restaurant. For example, in this case, is from the online webpage The Fork, when you write online reviews from restaurant. For example, an early result that we are getting is if we analyze the words according to the sentiment, the sentiment of the reviews, we're seeing a huge gender bias in the meaning of the word. And unfortunately or sadly, most of the positive reviews are related to, for example, are written to male waiter, waitress, helpful, he, his, etc. And when we're analyzing negative reviews that has a negative sentiment, people that are complaining, most of the time, they are talking about waitress, lady, and this kind of thing. They are really interesting results that now we are trying to understand why this is happening. And for example, without the transformer model, before we were not able to get this kind of information because the previous techniques and tools didn't have this performance capabilities. Okay, so that's everything on my side. Okay, so I give you back the floor to ask me any question that you may have. I am ready. So, okay.
Thanks a lot, José, for this great masterclass. Very timely, given the evolution of GPT. Yeah, let's open the question to the participants. You can write in the chat or talk.
Okay, great.
Yeah, we have a question, Nathan.
Hello, thank you for the interesting presentation. I was wondering if there were some competitive approaches to transformer models that have the same ambition, or if there's a consensus in the community that this is the best way forward.
Yeah, this is something that is really, in the state of art of the development. And currently, the transformer model are like the foundational part, of the models. They are now like the how to say the single unit, the transformer. Now they are combining with a different other techniques to extract more power. And now I am reading these days in the scientific community or research in computer science. And now the problem they are telling is that if you remember this, let me just quickly back to one of the first slides here of the evolution of the the evolution of the dimension of the transformer. So, okay, with the transformer we are getting but we are reaching a limit where now, we can increase the size of the transformer, but we are not getting better information with them. Okay, so it's not worthy. Also, it's really, in the term of the environment, it's really costly to train this huge model because you waste a lot of resources. And they are telling that the new evolution, the new disruptive evolution, is not to change the model per se, but to change the quality of the data. Because now it's not only, feeding with more amount of data and see what happens. Now the thing is, the challenge is to be able to get or to get better quality of data, to extract better quality of information from the data. So with the same model, you're getting better information, better quality of the information. So I think during this year, the new release, in development will come from this way, not only to develop new model, but to improve the current ones. But we will see. We don't know because 4 months ago we didn't know that ChatGPT could exist, so we don't know. And another thing which is interesting is like an evolution of the transformer are called the bimodal transformer models. which is like are similar to Dall-E or Stable Diffusion, are models that combine different kind of data. You don't not only have input text and the output is a text. For example, the input can be a text and the output an image, or you can have the other way around. For example, there's a really powerful release from this stability AI company. They released a model which is called Whisper. I don't know if you have heard about it. Whisper is a model where the input of the model is an audio, a voice, and it's able to translate to text automatically. So it's like, and you can put, a 1 hour recording transcription, and it's able to give you the transcription of the text, and in more than 50 languages. Able to understand more than 50 languages, and also in real time to translate you this text. For example, I have a recording of a conference, a meeting in, Chinese, but they want the real time translation in English. So they released this tool, for example. So no, I don't know any other kind of development that comes in this step, but it is like the more recent one that I have heard about. For example, this ChatGPT, Microsoft have virtually acquired the company, integrating on his platform. And I read a few weeks ago that Google, okay, we can lose the possibility that they are quickly going to train his own ChatGPT. I think in the following weeks, they are going to release his own version of ChatGPT, which is called a BART, I think. The name is BART. And I don't know if it's going to be, for free or again, just paid, but this is the model, and it's going to, okay. So
and
that's basically the idea.
I have a small question, José. Okay, given also as among the participants, there are also some professors from social science. If you consider transformer models in terms of research, application research, because you showed several applications for marketing or to analyze consumer behavior and also the examples you are mentioning now. But if you look at in terms of research, which problem they can address? The application of transformer model doesn't mean that so you have to work with someone that knows how to run a transformer model, of course.
For example, one particular problem I am facing currently is not related specifically with the transformer, but with the general research is the sources of the data. Maybe technical or legal issues with the use of these tools to process data, because we are in a frontier when we don't have faced before, and the technology normally evolves faster than the laws and the ethical development. So, for example, one issue that this transformer model had was, for example, this Dall-E 2 was trained with a lot of images from the internet. Most of them had copyright, or the same that GitHub Co-pilot. For example, there was a lot of programmers that they complained, okay, my own code from my company, which is private, has been used to train this model without my permission. So, for example, in research, it's a really huge, now important issue that we need, in the ethical point of view, take very well attention, because, for example, with the GDPR law, etc. For example, one of my research that I am doing now, okay, we are very close in discussion, for example, this BlaBlaCar, that with the legal department, to be sure that we are treating well this data. For example, I don't know, for example, you were asking about issues in the side of the social science researcher, no? For example. Another thing that I consider is really important is the importance of knowing these tools and these techniques, at least the very basic idea. You don't need to learn how to program them, but understand them. How do they work? To understand the output, because I have seen that a problem is that, it's not a problem, but okay, for example, okay, you are going to collaborate with a computer scientist like me. I am going to do the programming part for you. We are going to collaborate together, but it's really important for you for you, there's not, the social science researchers, to understand how this model works, to have a better understanding of the output, the output that the models give you. Because, for example, maybe I'm not an expert in marketing or in economics. So, okay, I can help you to develop these models, but I am not able to understand the output that is given to you. So I think here, in that point of understanding the output, of getting useful information for your research, is where is the real challenge, to merge, to build a bridge between these two worlds. Okay, I'm now, for example, I am learning a bit of marketing or economics, to understand better these things. Or apart from the side of the social side, research is really important to understand, okay, this is giving me these numbers, this output, but what are they, Because if not, you're not able to understand. Another problem which is really important is that not only for your personal, point of view, okay, I want to do good research, but how do I say kindly that to do, truthful research? Because one problem that I'm seeing a lot is many people use this model. Okay, this is the output, or this is my solution. I'm getting this result. I'm publishing this paper, but the results are not correct, or are wrong, are fake, are incorrect. Maybe they don't know. They are publishing something, getting some contribution, some answer to research questions that maybe they don't know because they don't understand well what is happening inside those models. So maybe they are getting different ideas of the result. So it's really, really important because it can give you a lot of misunderstanding in the research. So that's why, for example, I am, wanted to do this kind of presentation to say, okay, to encourage non-technical research, okay, but it's important for you to know these things, to know these tools. Okay.
Thanks a lot. Thanks, José. Are there other questions? Okay, there is Yitung, Iris.
Yeah. Okay, I think you are muted.
Yeah, you're muted, Iris?
Sorry.
Okay.
Yes, thank you. I have a small questions. Since you mentioned there in developing the AI model, there's always privacy data issues. I want to know how common it is for companies when they develop a model for them to share an AI input or AI technique or AI algorithm when they develop a new AI model, and what might be the challenges?
Yeah, to share this kind of models.
Yes.
Yeah, sorry.
Because I've seen, for example, ChatGPT is launched, and then the other companies they are launching similar products as well at the same time. And I want to know how easy it can be for the companies to learn from each other, or what's the difficulty of transfer of or copy and paste of the models.
Yeah, totally. No, it's really a really huge issue in this sense because it's like I don't know how to say well in English, but it's like what happened in the industry. For example, the military industry or the automotive industry. This kind of we're developing our technology that we don't want to share with the other companies to not lose what we are creating, etc. And this is one issue that I read the other day at an article that they are saying that the biggest development of this year wasn't ChatGPT. It was the open source, the transport, the application to open source of these models. Before, a few years ago, these companies own their own model. It were like a black box. No one knows how they work, how do they perform, because only this company were able to use it. But now, most of these models are open source. So you can download, for example, there are a lot of pages. The most famous one is called Hugging Face. I'm going to put here the name. Face. It's like a repository for machine learning models, and there you can find hundreds of models the source code or the already trained model for you to download and to use it. That's part of the competition, you know. The companies, they are getting, like imagine the basic model is the same for everyone. Okay, now, but each one is creating their own version. They have their teams of engineers to improve their models. Of course, they don't share the information. That's, for example, the case of this stable diffusion stability AI case. Okay, OpenAI developed this Dall-E model, but we didn't know how this model worked. So these people hire engineers from the company just to release to people this model. Okay, so I don't know if I answered your question, sorry.
There is also a question in the chat.
Yeah.
Maybe Nathan, I'll leave you.
Okay, sure.
Take your role.
No, don't worry. Yeah, about the trustfulness of AI. Yeah, this is a really huge issue. How do you trust this information, not this text that is being generated? And honestly, I don't have the answer, and I doubt that anyone has an answer currently from that. I think this is a really, really good challenge in the ethic AI point of view, that to develop this kind of things, because 1 year ago, we didn't have these problems. For us, it was impossible to imagine that artificial model was able to generate so realistic text that it was impossible to differentiate from a human operator, you know, visually. So it's really, really, really difficult. I don't know. Is how, for example, I don't know if you heard some news that in some university, they are facing a lot of issues because a lot of students are using ChatGPT to do their works, you know, their assignments, and it's impossible to know if this assignment, this text, was done from them or generated from ChatGPT. Actually, if you know, depending of the topic, etc. But it's really, because the thing is, you can copy a text and paste, and you don't know the source of the text. So maybe it can generate fake information, you know, and maybe it can contribute to the spread of fake news in the world. So it's a really, really, really huge challenge, and for the companies, that's the thing. For example, this OpenAI company, I saw an interview to the CEO of the company that they said that they still haven't released GPT-4, the new version of ChatGPT, because they are really concerned of this, because they don't know how people could use this tool in the future, and it's really, really like you know, really dangerous. No, can be really dangerous. So they are really taken with very little steps to be sure that they are releasing this tool, but really, you know, with a huge constraints to try to protect that it's not used for bad purposes, to the spread of fake news, etc. So it's a really, really huge challenge. I don't know. For example, this is it's on your side, social science research, to understand, to try to figure out how is the best way to solve this problem. I have no idea.
Great. So if there are other questions, maybe the last one. Otherwise, we close here. I know that some students connected have a class starting now. So thanks a lot, José, for sharing your expertise, your time, and joining us. This is a great occasion for all of us, really, to learn transformer model.